Welcome to a screencast for dilations. In this screencast, our objectives are to define a dilation, to dilate a geometric object on a grid or the coordinate plane. Let's take a look at the definition. A dilation changes the size of an object, but not the shape. And when it changes the size of the object, it changes them proportionally. So everything has to increase or decrease in the same way. One of the words that we'll be coming to is scale factor. Scale factor is the ratio of the image to the pre-image. When the scale factor is bigger than 1, the figure is getting bigger. We call that an enlargement. If our scale factor is less than 1, but positive, we call it a reduction. We do not usually refer to a negative number as a scale factor. We also have our center of dilation, and that is the fixed point about which all points are expanded or contracted. So let's take a look at an image. Here we have our center of dilation, our pre-image, and our image. So in this case, it was an enlargement. We would be expecting our scale factor to be bigger than 1. And what is interesting about the center of dilation is if you were to connect all of the corresponding points, they all lead back, connect the eyes, they all lead back to that center of dilation. So that center of dilation is kind of that common point when we think about the lines that connect our corresponding parts. So, in general, dilation is not a rigid transformation. Only the angle measures are preserved. The side lengths are not preserved. So again, dilation, basically same shape, different size. So how might we plot an image of point A under dilation if P is our center of dilation? And we're looking at a scale factor of 1/3. So we're looking for some kind of a reduction. We want it smaller, or we want our image to be closer to that point P. So to think about where A is in relationship to P, we could think about this as a diagonal length, but diagonal lengths are not always the easiest to count. We would have to use a distance formula. So I like to think of it in terms of vertical and horizontal distance. So we had a vertical distance of 9 and a horizontal distance of 12. So that distance to get from P to A, what I would have to do, moving vertically and horizontally, is up 9 over 12. But that's for where my pre-images, I would like the image of A. So instead of moving vertically all the way up 9 points, I want 1/3 of 9. I want 3. So consider that point P, I'm only going to move up 3 points instead of the whole 9. And then in terms of horizontal, I only want to move 1/3 of the horizontal distance of 12, which means I'm only going to want to move 4 horizontally from P. So I am going to expect that my pre-image, there's my pre-image, my image of A, or A prime, is going to be right there. So we scaled it down from a factor of 1/3. And again, if we think about it, when I draw this line connecting A and A prime, it's going to get me right to my center of rotation. Let's look at another example. This time we're going to plot the image of a triangle around this point P. And it's going to be a scale factor of 2, so I'm expecting some enlargement. There is a formula. When you look at the formula, it looks like alphabet soup. It's not worth it to memorize the formula for dilating around a point that is not the origin. What I'm going to do is the same strategy that I used for the previous problem. I'm going to take a look at each point and how far away it is from the center of rotation. So A would be up 3 over 4. Instead of moving up 3, I want to multiply that by 2. That's my scale factor. So I would want it to be 6 units away vertically. Horizontally, instead of 4, I want it to be 8 units away. So that's where A prime would be. Let's look at point B and B prime. B was 2 over, 2 up. Sorry, it was over 1, up 4. So this time I want to go over 2, up 8 from the center of rotation. And for C, which was down 2 over 2, multiply that both of those by 2, I want to go down 4 over 4. So that is what my image is going to look like after I enlarged it by a factor of 2. So hopefully you've got some strategies on defining a dilation and also strategies for how to dilate a geometric object on the grid or the coordinate plane.